Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are starting another chapter of class 10th, that is constructions. Exercise, let us start exercise 10.1. Let me have the first question. Draw a line segment of length 7.6 centimeter and divide it in the ratio 5:8. You need to draw a line segment of some given length, then you need to divide that line segment in the ratio of 5:8, then measure the two parts. Now let us see how these kinds of questions are done. What you see, if you are given with any line segment and you are asked to divide that line segment, so you do the same procedure for those questions. What I'll show you here. This is question number 1. So we have a line segment. I'll show you here steps to construction as well. Steps to construction. Now first of all, we need to draw a line segment. First step, draw a line segment. Draw a line segment. Draw a line segment of length 7.6 centimeter. Let us draw a line segment of this length. So you go like this. With the help of a ruler, you can draw it easily. Just like this. And let me name this line segment. Let me name the line segment first. Draw a line segment B, AB or BC, say AB of length 7.6 centimeter. So in that case, this is your AB and this length is 7.6 centimeter. Now you need to divide this line segment. You cannot just go directly and make a division, make a point of division, because you don't know. You need to cut that in the ratio 5:8. How would you decide that? So what we do, now the next step is draw a ray AX such that angle BAX is an acute angle. Draw a ray AX, simply AX such that angle BAX is an acute angle. So BAX, you can write upwards or downwards, that's up to you. Let me draw like this. This is X. So draw a ray AX such that BAX is acute angle. Now we observe that BAX is an acute angle. Now the next step, divide AX. Divide AX into 13 Why 13? 13 equal parts. Why 13? Pay attention here. If you need to divide a line segment in the ratio 5:8, that means adding the numerator and denominator you get 13. 5 plus 8 you get 13. So that's why we divide this ray into 13 equal parts. Had it been the case, the ratio is 3:2 suppose, then you do 3 plus 2, that is 5, so you divide AX, that ray, into 5 equal parts. So in general, if your required ratio of line segment is m:n, that means you do m plus n equal parts. M plus n equal parts. Divide AX into 13. Why 13? 5 plus 8 is equal to 13. What is this 5 plus 8? This is your required ratio. 5:8, yes. So divide AX into 13 equal parts through A. You start from A. Through A, say A1, A2, A3, so on and so forth, A13. So let you name those parts, those intersecting points with the ray as A1, A2, A3, so on and so forth, A13. What do I mean? But the question is, how would you do that? You take a compass with A as center and any convenient radius, draw an arc. Then for example, you start from A with A as center, I repeat, with A as center and any convenient radius. Let us say you go like this. So that's one. Then with this point as center, same radius. Draw another arc and go on continuing till you reach that A13. 13 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So these are your 13 parts. Let me name them: A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12 and A13. You got it? Now the next step. Next step is join B with the last point, that is A13. So join B, A13. Join B, A13. So let us join this. Just like that. Then next thing is, now if your required ratio is m:n, then you need to look at the smaller one. You need to look at the smaller one. So for example, here our ratio is 5:8. Then go for the smaller one. Go for the smaller one, that's our numerator, that's 5. So in this case, if ratio is m:n, the smaller one, you take smaller one, that m is the smaller one, so take m. Or you just remember like this, numerator, you can take here numerator. For example, because it works. If your ratio is m:n, then take m, numerator. You got it? Now here, Our required ratio is 5:8, so we take 5. So by 5 we mean that from A5 we will draw a line which will be parallel to BA13. So from A5 draw a line parallel to BA13. Why A5? Because of the numerator. So our step is from A5. From A5, draw a line parallel to BA13. Let me just write down the reason here first. From A5. Why A5? Five for m is to n, taking m implies for 5:8 taking 5. Did you get the reason? For m is to n taking m implies for 5:8 taking 5. So that's why we have A5. From A5, draw a line parallel to BA13. Parallel to BA13. Intersecting. Now when you draw a line parallel, that will for sure intersect AB at some point. So let's say that point B, say C, intersecting AB at C. Intersecting AB at C. Go like this. Now see. Now the question is, how would you draw a line parallel? See how. First of all, what you do with A13 as center, take a compass with A13 as center, any convenient radius, take any convenient radius, draw an arc. So you go like this, with A13 as center, then draw an arc. For example, you go like this. Got it? So, with A13 as center and any convenient radius, draw an arc intersecting this AX at some point and BA13 at some point. Now, with A5 as center, from the point where you need to draw the line parallel, from A5 with A5 as center and the same radius. Now, do not change the radius. With A5 as center, same radius, draw an arc. So you go like this, then with A5, same radius, so you draw one more like this. With A5 as center, same radius, draw another ray, intersecting A13 at some point here. There. Then with that point as center, and radius from here to here. You got it? Where it intersected, where the previous ray intersected AX and BX, take that as radius. So from this point to this point, with this as center, with this point as center and radius from this to this, draw another arc like this. Draw another arc intersecting the previous arc at some other point. Then join A5 and this point. just like this. So you will automatically get the line parallel to BA13. See this line now intersecting AB at C. Now CA5 is parallel to BA13. So from A5, draw a line parallel to BA13 intersecting AB at C. Because we have already read in the previous classes how to draw a line parallel to some other line from a given point. That's what I did. And here, what's the catch here? What actually we did? We made actually this angle and this angle equal. So these are corresponding angles. When corresponding angles are equal, lines are parallel. That's the main point about that actually. So next step. Oh, we are done. Now if you see, AB is divided into AC and CB. This is your given ratio, 5:8. Therefore, AC is to CB. AC is to CB is equal to 5:8. AC is to CB is 5:8. You got it? Now after that, question says justify the construction. You need to justify the construction now. How would you justify the construction? See. Let me just rub it now. These are the steps. Make a note. Now next thing you do is justification. Justification. Let us justify that AC is to CB is 5:8. See, consider triangle AB-A30. AB-A30. Consider triangle AB-A30. Since in this triangle what you observe, CA5 is parallel to BA13. CA5 is parallel to BA13. Why? By construction. Because we drew a line parallel by construction. In a triangle, if one line is parallel to one of the sides of the triangle, then you know by Thales' theorem, the remaining two sides are cut out in the same proportion, which implies that, so in that case I can say A5 or AC by CB is equal to A5 by AA5 by A5A30. Simple basic proportionality theorem, or you can say Thales theorem. AC by CB is equal to A5 by A5A30. The reason for this is Thales theorem. You got it? However, but one thing we know that if AA5 by A5 A13 is nothing but 5 by 8. What? A5 by A5 A13, because these are 13 equal parts. Now from A to A5 there are 5 parts, 1, 2, 3, 4, 5. Then from A5 to A13 there are remaining 8 parts, 1, 2, 3, 4, 5, 6, 7, 8. So we know this is 5 by 8 again by construction. As we constructed this, so from this and this what you got? Which implies that from here and here, this is equal to this and this is equal to the same thing, so this is equal to this. AC by CB is equal to 5 by 8. Therefore, AC is to CB is equal to 5 is to 8. You got it? Hence, justified. Hence, justified. Then you have to measure. Then number 3rd comes measurement. In measurement, what you're going to do, you're going to measure the 2 parts. So that's simply AC is equal to, or measure AC. Simply with the help of ruler you can measure AC. Then you can measure CB. Therefore, AC plus CB is equal to that plus that. What you will get here and here. That will give you 7.6 centimeter. And you'll come to know the exact addition sum of this and this is 7.6 centimeter. Make a note. Then let's have question number 2. Question number 2 says, construct a triangle of sides 4 centimeter, 5 centimeter and 6 centimeter. Then a triangle similar to it whose sides are 2 by 3 of the corresponding sides of the first triangle. See, first of all we'll construct a triangle of sides 4, 5 and 6 centimeters. So it's simple, you know how to construct a triangle with sides. You have already learnt that in your elementary classes. So I'll just go quickly. So first of all, steps of construction, I'll write here steps to construction. Now the first step is 4, 5 and 6 are the sides of the triangle. So let me make the larger one. It goes like this. Let me name this BC. Because let us say ABC is a triangle, so BC. Draw a line segment. Draw a line segment BC of length 6 centimeter. Then the next one, with B as center, with B as center and radius 4 centimeter, draw an arc. So with B as center, draw an arc on either side of BC with B as center and radius 4 centimeter, draw an arc. So it goes like this. On either side, you can go here or here. Then the next step, with C as center, and radius 5 centimeter, draw another arc. Draw another arc intersecting the previous arc at A. Intersecting the previous arc at A. So with C as center, radius 5 centimeter, draw another arc intersecting the previous arc at A. Then the next step, join AB and AC. Join AB and AC, so you get a triangle ABC. Now, so this was the first part of the question, that first of all we drew a triangle ABC. Now you need to construct another triangle similar to this triangle, such that their sides are in proportion by 2:3. So let us draw similar triangle to this first. What we will do again, draw a ray BX. Draw a ray BX. Draw a ray BX such that angle CBX is an acute angle. So you go like this. This is your X. Then what we did here, BX ray such that CBX is an acute angle. Acute angle means, for example, you have this is acute, 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 acute. If this is initial side and terminal side, then this is 90 degree, right? Then this makes obtuse, 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 and then straight. Then it goes reflex. You know this. Then remember in previous question what we did when we drew the ray, we divided ray into 13 equal parts because of the sum of m:n. If our ratio was m:n, then we added the m and n, so we got 13. So we divided the ray into 13 equal parts. But here what we will do, if our ratio is m:n is our required ratio, in which we have to construct another similar triangle such that the ratio of this triangle and that triangle is 2:3 sides, the ratio of the sides rather. So m:n is, if m:n is our required ratio, then what we will do here, we have to first observe that whether m is greater or n is greater. You got it? So there are two kinds of possibilities here. Number one is m:n is a proper ratio or proper fraction. Number two possibility is m:n is an improper ratio or fraction. What do we mean by that? In the proper ratio case, in this case, m is less than n. M is less than n. And in this case, m is greater than You got it? So there are two cases possible. Our case is 2:3. 2 by 3 is 2 by 3. Yes, 2 by 3 ratio. That means our case is 2:3. Or you can say 2 by 3 is our case. The ratio of sides and the ratio of 2:3 or 2 by 3 proportion. So our case is the case first, proper ratio or proper fraction where numerator is less than the denominator. You got it? So we have to deal with the case first. There are different procedures for case 1 and case 2. Here we are dealing with first here we are dealing with case first. That is 2 is less than 3. Now what we will do here? We will take the larger one. Which is the larger one? 3. So divide bx into 3 equal parts. Why 3? Because larger of the two. So divide bx into 3. Why 3? Larger of 2 and 3. 2 and 3 in 2 by 3. So divide bx into 3 equal parts through b, say, and let us name them b1, b2 and b3. So we do like this. How would you do that? With b as center and any convenient radius, draw an arc intersecting bx at b1, then with b1 as center, go with same radius, draw another arc intersecting bx at b2, then b2 as center, so on and so forth. So we have like this 1, 2, and 3. Name them b1, b2, b3. Got it? Then next step, join CB3. CB3. Join CB3. Then from B2, why B2? The left over here. If you divided the ray into 3 equal parts, then from B2. Had it been the case that our ratio would have say 5 by 7, then you would have divided Bx into 7 equal parts, then you would have drawn line parallel from B5. You got it? So here we divided 3 equal parts, then draw from B2. Very good. So from B2, draw a line parallel to CB3. From B2, draw a line. Why B2? Smaller of 2 and 3 in 2 by 3. From B2, draw a line parallel to CB3 intersecting BC. Intersecting BC at say C dash. intersecting BC at C dash. How would you draw the line parallel? Exactly in the same way as I just showed you in the previous question. So with B3 as center, you'll first draw like this, then go here like this, and with this as center and this much radius, you go accordingly like this. Then you just join this and this. So this point is your C dash. Got it? Make a note, I'll just rub it out. Then comes your ninth step. From C dash, draw a line parallel to AC, intersecting AB at A dash. So from C dash, draw another line parallel to AC. Again, you will do the same thing. Just like this. With C as center, draw an arc of any convenient radius. Then with C dash as center, draw an arc with same radius. Then with this point as center and radius this, like this. Draw an arc intersecting that arc at some point. Then join C dash and that you'll get a line parallel to AC. And let's name this as A dash. So that's what I do. From C dash, draw a line parallel to AC intersecting AB at A dash. Your turn. Therefore, what you did, triangle ABC is similar to triangle A dash B C dash. A dash B C dash. A B C is similar to A dash B C dash because this is also a triangle. So that's it. And let us justify our case. Let us have a justification. In justification, we need to prove that this triangle is similar to this triangle in such a way that their corresponding sides are in the ratio 2:3. Consider triangle ABC and triangle A dash B C dash. Consider these two triangles. Since what you observe, I can say angle ABC is equal to angle A dash B C dash. Common. You see carefully, ABC, this angle, A dash B C dash, this angle, so it's a common angle. Another thing I can say, ACB is equal to angle A dash C dash B. A dash C dash B. Why? Because we constructed parallel lines, so these are corresponding angles. Corresponding angles. Therefore, you can say triangle ABC is similar to triangle A dash B C dash. So half of our job is done. Triangles are similar by angle-angle similarity criterion. Angle-angle similarity criterion. Then you know, you have read it in triangles that when two triangles are similar, their corresponding sides are in the proportion. That means then AB, when AB by A dash B, AB by A dash B is equal to AC by A dash C dash is equal to BC by BC by BC dash. You got it? Whose sides are 2 by 3 of the corresponding sides of the 2 by 3 of the first triangle. Okay. Now AB by A dash B is equal to AC by A dash C dash is equal to BC by BC dash. Sides are in proportion, or you can write CPST, corresponding parts of similar triangles. Now after that, what we'll do, which implies that or just do one thing, or do here invertendo. Now taking reciprocals throughout, what you will get, A dash B by AB is equal to A dash C dash by AC is equal to BC dash by BC. There is no need to do the reciprocal if you would have started from this. Therefore, triangle A dash BC dash is similar to triangle ABC. Then you would have considered A dash BC dash and ABC, the opposite of it. Then you go like this, and you would have got the same result. This is invertendo. Invertendo. You got it? Okay. Let us call this as equation first. Then after that, consider triangle. Let me just rub it, make a note. Now consider triangle, this one, BC dash B2 B, C dash B2, and triangle BC B3. You got the two triangles? Since What you observe in these two triangles, since angle B2B, angle B2BC dash is equal to angle B3B C is common. So this angle is a common angle in both the triangles. Number 2, angle this one BB2C dash C dash is equal to angle BB3C. Yes, corresponding angles. Therefore, triangle BC dash B2 is similar to triangle BCB3. BC dash B2 is similar to triangle BCB3 by angle-angle similarity criterion. Then again, sides will be in proportion. So let me take this one. Then BC dash by BC. BC dash by BC is equal to BB2 by BB3. BB2 by BB3 is equal to the third one. I need only 2, so there is no need to write the third one. You can write CPST. CPST, corresponding paths of similar triangles. Now let us, however, one thing you know, that BB2 by BB3, it's nothing but 2 by 3. See, BB2 are 2 parts, BB3 are 3 parts. 2 by 3 by construction. Then let's call this as second. Now observe first and second. First says that this is equal to this is equal to this. Second says this is equal to 2 by 3. So this, sorry. Don't take this as first. By construction, then you can make one thing that, see, BC dash by BC is equal to BB2 by BB3, but BB2 by BB3 is equal to 2 by 3, so this is equal to BC dash by BC is equal to 2 by 3. From this and this you got, this is equal to this. Yes? Then name this as second. Now from first and second. From first and second we get, now see, first says this is equal to this is equal to this. Second says BC dash by BC is equal to 2 by 3. BC dash by BC is equal to 2 by 3. So all of these are equal to 2 by 3. From first and second we get A dash B by AB is equal to BC dash is equal to A dash C dash by AC is equal to BC dash by BC. BC dash by BC is equal to 2 by 3. So this justifies your construction, hence justified. Make a note. Then question number 3. Construct a triangle with side parallel. And again you can do the same thing, but this time you have the ratio 7:5. That means it's an improper ratio. Now here, I'll leave this question to you. I'll show you question number 4, because question number 4, by question number 4, we will learn two things simultaneously. Number 1, how to construct an isosceles triangle if base is given, and number 2, when improper fraction is given, then at that time, how would you establish the similar triangle to the given triangle. Let me show you question number 4. Question number 3, I'll leave it to you. Question number 4. Construct an isosceles triangle whose bases, let me just give the rough sketch, a rough idea first. You need to construct an isosceles triangle. Let us say like this. Construct an isosceles triangle whose base is 8 cm. Let us say the name is ABC and base is 8 cm. And altitude 4 cm. Altitude is 4 cm. And then another triangle. Then you need to draw the triangle similar to it, which follows the same procedure as the earlier one. Let us start. Let's have the steps to construction. Step number 1. First, we need to construct this triangle. How do you do that? Let us start with the base. Draw a line segment BC of length 8 cm. Draw a line segment BC of length 8 cm. Then the next one, draw a perpendicular bisector, because you know an altitude of an isosceles triangle is the median of it as well. So draw a perpendicular bisector of BC. Draw a perpendicular bisector of BC intersecting BC at say D. Let us say this point is D. At D. Perpendicular bisector, you know how to draw it. Let me just give you an idea. Perpendicular bisector looks like something like this, with VS center, radius here, arc here, then with CS center, intersect the previous arcs, then join this and this, you'll get. So this line is perpendicular to BC as well as bisector of BC. Let's name this point as D. This point is your D. You got it? Then number 3, with D as center, with D as center, and because the length of the altitude is 4 cm, so with D as center and radius 4 cm, draw an arc. Draw an are intersecting the perpendicular bisector at A. Where this intersects perpendicular bisector, that will be our A. So with DS center and radius 4 centimeter, so it goes like this. Like this. And this is our A. Got it? Then the fourth point, join AB and AC. Now join AB and AC. So that's your required isosceles triangle. You got it? Now the next step. Now we need to construct another triangle which is similar to this triangle, such that their sides are in the ratio 1 by 2. 1 by 2 means it's in the mixed fraction, that is 3 by 2. Again, draw a ray BX. Draw a ray BX such that angle CBX is an acute angle. So you go like this. Let us say this is x, so BX such that CBX is an acute angle. Then divide BX. Divide BX into 3. Why 3? Because our ratio is 3:1, larger of the two. Larger of 3 and 2 in 3 by 2. Got it? Because 1 by 2 is 3 by 2. So larger of the two is 3. That's why we are dividing into 3 parts. Divide BX into 3 equal parts through B, say B1, B2 and B3. So it goes like this. 1, 2 and 3. B1, B2 and B3. You got it? Now, in this point, here is the difference. See, previously what we did, we joined CB3. This time, we'll do the opposite. We will join CB2, smaller of the two. Earlier also it was smaller of the two, but it was the last point, our points were B1, B2, B3. The last point being the larger one, hence we joined CB3. This time we will join CB2, smaller of the two. Okay. So join BX into 3 equal parts through B. So join CB2. Why B2? Because smaller. Join CB2. 2 being smaller of Got the reason? Join CB2. Reason is 2 being smaller of 2 and 3 and 3 by 2. That's 1. 1 by 2. Okay. So join like this. Now 8th point. Now from B3, draw a line parallel to CB2. From B3, draw a line parallel to from B3, draw a line parallel to CB2. CB2. Why from B3? The larger of the two. Two and 3 in 3 by 2 is equal to 1 by 2. So from B3 draw a line parallel to CB2 intersecting. Now when I draw a line parallel from B3, it will not intersect anywhere. No, it will not intersect AC anywhere, but intersecting the extension of AC. So it will work like this. Intersecting the extension of AC at, let us say C dash. The extension of from B3 draw a line parallel like this. Then from this point draw a line parallel to sorry. We just got one thing wrong. Not extension of BC. Intersecting the extension of, not extension of AC, intersecting the extension of BC. Just like this. Intersecting the extension of BC at C dash. Intersecting the extension of BC at C dash. So it works like this. Got it? Then from C dash, draw a line parallel to AC, intersecting the extension of AB at somewhere. Let us now have the extension of this AB, then from C dash draw a line parallel to AC intersecting the extension of AB at A dash. Now how would you do the line parallel? Exactly in the same way. intersecting the extension of BC. Then the ninth step is from C dash draw a line parallel to AC intersecting the extension of AB at A dash therefore triangle A dash B C dash is similar to triangle ABC. That's it. So hence constructed. Hence constructed. Did you get this one? Again, how would you do the line parallel? Exactly in the same way we just learned in the previous questions. Make a note. Then after that, you need to justify your construction. You can justify this construction exactly in the same way by considering this triangle and this triangle. One angle is common, one is corresponding angle. You first take triangle, this and this triangle. Take this triangle and this triangle. One angle is common, that's angle B, and this angle is equal to this angle. Corresponding angles, that means sides are in proportion. Then write down the three proportional sides. Then consider this triangle BB2C and BB3C dash. In these triangles, this angle is common. Then this angle is equal to this angle. Corresponding angles. So again, these are similar. Then in this case, take two sides BC dash by BC is equal to BB3 by BB2. Got it? But BB3 are three parts, BB2 two parts, so 3 by 2. BB3 is 3 by 2. So that means this is also 3 by 2. Now this is the side of this similarity, BC dash by BC. So all of three sides of this similarity are in the ratio 3 by 2. This justifies your construction. Hope you understand that. Then after that, question number 5 and 6 are based on the same concept. All you need to do is just construct a triangle first. When you have read that in your earlier classes, how to construct a triangle when base angle is given and base is given. How to construct a triangle when two angles are given. Then first of all you can apply the angle sum property. You'll get the third angle. Then you can construct a similar triangle accordingly. So I'll leave 5 and 6 for you. Let me show you exercise 10.2. Exercise 10.2. Question number 1. Question number 1 says draw a circle of radius 6 centimeter. You need to draw a circle of radius 6 centimeter. So let's have steps to construction here. Step number 1. Draw a circle of radius 6 centimeters. So simply draw a circle with center O of radius 6 centimeter. So let us draw it. Circle of radius 6 centimeter. Let us say this is a circle. This is a circle with center O of radius 6 centimeter. Now step 2. The question says from a point 10 centimeter away from its center, take a point. Now question says from a point 10 centimeter away. Let us say P is a point which is 10 centimeter away from the center. From that point construct 2 tangents to this circle. That's your question. So take a point P 10 centimeter away from O. Simple. So take P 10 centimeter away. Let us say this point is P. Take P 10 centimeter away from the center. Then the next one. Then join OP. Join OP. So let us join OP. Let me just join it correctly. Got it? Okay. The next step is draw a perpendicular bisector of OP. Draw a perpendicular bisector of OP. Draw a perpendicular bisector of OP. Perpendicular bisector of OP looks like this. Perpendicular bisector of OP looks like this. Draw a perpendicular bisector of OP intersecting OP at, let us say, M. At M. So this point is M. Now with M as center and radius OM, since it's a perpendicular bisector, so that means OM is equal to MP, because perpendicular bisector bisects this OP. OM is equal to MP. Now, next step, with M as center, with M as center and radius OM or MP, because it's the same thing, draw another circle. Draw another circle intersecting the given circle, at, so when you draw a circle like this, just like this, it will intersect the given circle at 2 points. Let us say those points are A and B, intersecting the given circle at A and B. So let us name this as A and this as B. A, B. The next step, join PA and PB. Join PA and PB. You got it? And so what do you observe? These are your required tangents. These are the required tangents. Therefore, PA and PB are the required tangents. Hence, constructed. Now you need to justify the construction again. Let's have the justification. In justification, you need to prove that these are the tangents. See, what I'll do, let us join this and this. Join OA and OB. Got it? Now, OP, now M is the center of this second circle and OP is a chord of the second circle. This chord passes through the center M. That means whenever a chord passes through a center, that chord is a diameter. So we can say OP is a diameter of this second circle. Okay. If OP is a diameter, so that means this arc OP, this arc or this OP, this is a semicircle. Yes. Now if you pay again attention, semicircle. Now A is a point on this semicircle. Yes. And angle OAP. Angle OAP is an angle subtended by the diameter on the semicircle. So that is the angle in the semicircle. You know angle in a semicircle is a right angle. That means it's a 90 degree. And OA is the radius of the previous circle, a given circle. Radius is perpendicular to a line, and you know that line is nothing but a tangent to the circle. So we prove, similarly we will prove that thing from here. You got it? Since OP is a diameter of OP is a diameter of circle with center M. Therefore, angle OAB is an angle subtended by a diameter on the semicircle, which implies that angle OAB is equal to 90 degree. Angle OAB is equal to 90 degree. Therefore, OA, which implies that OA is perpendicular to PA. OA is perpendicular to PA. Therefore, PA is a tangent. PA is a tangent to a circle with center O. To a circle with center O. Reason? Reason is as radius is perpendicular You have learnt about this theorem in chapter circles. So you are done, hence justified. Hence justified. This justifies your construction. Then after that, you need to measure their lengths. Now, next thing is measurement. In measurement, just you need to measure the length of this PA is equal to PB. This is another term of circles, that from an external point, length of the tangents drawn is equal. So PA is equal to PB is equal to, just check the length. That's your answer. Make a note. Then let us have question number 2. Question number 2 says, construct a tangent to a circle of radius 4 cm from a point on the concentric circle. So we have a concentric circle. Concentric circles are the circles with same center. So let us say these are concentric circles. Construct a tangent from a circle of radius 4 cm from a point of concentric circle radius 6 cm. The bigger one is of radius 6 cm and the smaller one is of radius 4 cm. So we have a point somewhere on the bigger circle. Let us say here, this is O, this is P, for example. Then it says that from P, draw a pair of tangent to this circle. Again, you will do the same thing. Join OP. Got it? Then draw the perpendicular bisector. Intersecting OP at M. Then with MS center and radius OM or MP, draw another circle. Intersecting the smaller circle at 2 points. Let us say A and B. Then join this PA and this PB. Got it? So these are your required tangents. Then for the justification, you will join this and this, and you get this angle in the semicircle. That's it. So you can do it in the same way. Then question number 3. Question number 3 says, draw a circle of radius 3 cm. So you will draw a circle of radius 3 cm. Then take 2 points P and Q on one of its external diameters, each at a distance of 7 cm. It says that diameter is extended to 7 cm. P and Q are extended diameter each at a distance of 7 cm. Now extend the diameter such that the extended point is 7 cm away from the center. So it looks like this. From here to here it's 7 cm, from here to here it's 7 cm. Name this as P and name this as Q. Now from this P and Q, draw a pair of tangents to the circle. Tangents to circle from these 2 points. Again it's simple. In this O, you will first draw from P, then from Q. So procedure for PO is same as the earlier questions, then the same procedure follows for OQ. Perpendicular bisector of this. intersecting this at M. Now with M as center and radius MP or MO, draw a circle. Then from intersecting the given circle at A and B, then join BA and join BB. These are your required tangents. Then for construction, you can join this and this. Angles in the semicircle. This is 90 degree, 90 degree. That proves your construction. Do the same thing for Q, for perpendicular bisector. Let us say this time it intersects at N. With N as center, draw another circle. Intersecting the given circle at, say, X and Y. Then join this, OX and OY. So these are your required tangents. Then for the justification, you will prove this is angle in the semicircle and this is angle in the semicircle. It looks like this. You got it? Now the last question. Draw a pair of tangents to a circle of radius 5 cm. We have a circle of radius 5 cm. Let us say this is a circle of radius 5 cm, which are inclined to each other at an angle of 60 degree. It says draw a pair of tangents like this, like this. Let us say this is B, pair of tangents, say A, B. And it says that this inclination of these two tangents is 60 degree. You need to draw this. But how do you do that? This is radius, O. One thing you know, this is 90 degree, this is 90 degree. One thing you know that OBPA is a quadrilateral, and in a quadrilateral angles and properties 360 degree. This is 90, 90 plus 60 and plus what? 120. So this angle must be 120 degree. So what you will do, you will just start with a circle like this. So draw a circle of radius 5 cm, center O. Then what you will do, take any arbitrary point A anywhere on the circle. Let us say I'll take it here, point A. Then join OA. Join it, just join it bold. Join OA. Then from this point, which angle goes out? 90 degree. Then at A, make an angle of 90 degree. Take this as base and this as point, make an angle of 90 degree. You know how to do that. Just like this. And this is 60, this is 120, then one arc here, one arc here. Then you join like this. And this is your 90 degree. Let us say this point is something X. This is not your P, because P is the point of intersection of these two tangents. Okay. Then from this point here, which angle goes 120? Then at O, make an angle of 120 degree. At O, make an angle of 120 degree. So you go like this with O as center, radius, any convenient radius, draw an arc. Then with this point as center, this is 60 and this is 120. Then join with this. Name this point as B. Then do the same procedure at B, make an angle of 90 degree, which goes like this, 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 this and this. Intersecting the ray AX at B. So you'll get this angle as 60 degree. You got it? And that's how you construct pair of tangents which are inclined each other at an angle of 60 degree. You got it? Make a note. Hope you understand all this. See you next time. May Allah bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.